This is a CAT 2017 slot 2 question. If you are well prepared, this question should be an easy one for you. And we are going to solve it in two ways. One, how a academically very bright student who knows his maths inside out, how he would have solved it. And also we will solve it in a very logical way and see that the logical way is a stepping stone to the sort of formulaic way. The formulaic way, there's a lot of story behind it. So if you know the story, the formulaic way becomes very easy. But if you don't know and you're mechanically doing it, then you're not going to improve in maths, right? So let's compare that. So before I go to this question, one commercial message. Just we are starting off a course for CAT 25, only the QA section, which includes live online classes. So Monday, Tuesday, Thursday, Friday, 9 p.m. you attend, you sit through a live class 1.5 to 2 hours and we'll be completing the entire syllabus for you. The details are in the description below. Read through it. I'll not waste more time in that over here. So there are three mixtures. Mixtures, I don't know why it tends to put off some students, though these are the easier ones, as I said earlier. The first having water, focus and liquid A in the ratio. So that's your typical like a milk and water solution. Okay, but it's liquid A and water. The second having water, so water is same and now this is liquid B and not A. Also water is coming as common in this, but there you had milk, here you had something else. Yeah, here you don't have milk, you have something else. Okay, the ratio. And the third having again water is coming in, but this is yet a third part, right, in the ratio 1:4. So okay, now these three mixtures of A, B, C respectively are further mixed in the proportion 4:3:2. So this is like your weights, the three mixtures, the three vessels, where this containing water and A, water and B, water and C, the volume of those vessels are 4:3:2, they all are poured into a single thing, and the resulting mixture has same amount of water and B, liquid B and C, and whatever it is, right? So the logical simple way is, we realize something different in the sense of here you don't just have milk and water, you have water which is present in all the three, but you also have liquid A, liquid B and liquid C, and I would also be talking about the total. So in the first solution I am given that there's water and A in the ratio 1:2, and that 1:2 I will add it up to the total also. Why total volume? Because this is the total volume, the volume of entire mixture, of the mixture, right? It's not a water, not a way of the both together. And the second one is water and B in the ratio 1:3, so the total will become 4. And the third has A, water and C in the ratio 1:4, the total will become 5. So this is what is given. And now these total, I need to change these totals such that they are in the ratio 4:3:2. So pay attention to a nice technique now, because this technique can be used even in other questions. So how do I manipulate these numbers such that they end up being in the ratio 4:3:2? So the simple thing is, first I would try to make them equal, all of them. And to make them equal, I need a multiple. Okay, a common multiple of 3. So this can change in 3, 6, 9, 4, 8, 12, 16, 5, 10, 15 multiples. So the common multiple, and why go to bigger numbers? So I'll look at the least common multiple is going to be 60. So I'll make them all 60. I'll multiply the first by 20, by 15 and by 12. But I'll not do it in piecemeal approach. Once I get them as 60, once I get them as equal, then I will multiply the first one by 4. The second one I'll multiply by 3 and the third one I'll multiply by 2. Okay, then what happens is, if they equal, the ratio is 1:1:1, and then when I multiply with this, it will become in the ratio 4:3:2. That's it. So these numbers I will quickly change them. Okay, so I made it 60 into 20 and then again into 4. Okay, so do it this way. So 60 was there, 60 into 4 is 240. So I've made that 240. And if this is made 240, you're multiplying it by 80. So both these will also get multiplied by 80. Let's try it again. This became 60 and 60 was multiplied by 3. So this becomes 180. 40 became 180. How many times? Divide by 2 is 90, divide by 2 is 45. So into 45. So this will be 45 and this will be 45 into 3. You should know these tables, students. Yeah, 45 into 3 is a very simple number. 5 became 60. 60 was multiplied by 2, so it became 120. 5 became 120, so 24 times. 24 ones are 24, 24 fours are 96. Okay, now what happens is, if you look at these numbers are in the ratio 4:3:2. 60 into 4, 60 into 3, 60 into 2. So what it means is, if I take 120k liters of this one, then this will also be 180k, the same constant, because the ratio I want it to be 3:2. So the 3:2 is already present in 120 and 180, so the k should get cancelled, it should be the same. So, and if those are k, these all are in terms of k, and I don't need to write this, I have to just doing it to explain it to you. And when I mix them up, I just add them up. So this is 120, 149k is water, 160k is your A, 135k is your B, and 96k is your C. So does it have the same amount of water and B? B is this? No. Does the B and C are same? B and C are same? No. Is there more water than B? Water, B. Yes. Is there more water than A? A is 160. No. So C is my answer. Simple. Now, so this is a little logical. If you remember what I said, this is like a stepping stone. Yeah, you need to know this background in the picture, and once you know this background in the picture, you can move ahead to how someone is not going to reinvent the wheel and do all this mechanically all the time, right? Someone will just use once these questions become chiller for me, like, hey, these are very, very easy ones. Then I'm directly going to go to the weighted average one, and I'm going to say, hey, listen, when I mix, it's a question, it's an application of weighted average. Water is present in all the three. The proportion of water is 1/3, 1/4, and 1/5. And they are mixed in different volumes. So that acts as the weight. So this is your weight. So this is going to be the proportion of water in the final. And water is present in all three, so you have this work. But for A and B, if water is 1/3, A is going to be 2/3 of it, and its volume is just B. For B, C is very easy. If water is 1/3, B is going to be 1/4. Sorry, B is going to be 3/4. The weight is same. And for C, if water is 1/5, C will be 4/5 and 2. So you find the proportion of water, A, B and C, and then you can do the comparison. Why I have written this down is to show you that the work over here and here is almost identical. When you want to do this, you are invariably going to take the LCM, and the LCM of 3, 4, 5 is 60, the one that we were doing over there, 60. And when you multiply, when you take the LCM as 60 and you multiply this by 60, 3, 20, 24s are 80, you get that 80. When you multiply make this 60, it's 15, 15 3s are 45, you get this 45 also. And here this becomes 12 2s are 24, you get this 24 also. So whatever work you are doing here mechanically, in terms of transferring the numbers, here you are doing it mechanically. Okay, so the micro calculations are going to be the same, students. There's no difference there, right? And here you will find these again, and to compare them, if you keep all of them by 60, you'll get the same numbers here, right? So you should, it's not a question of either or, students. CAT is a tough exam. You cannot say I'll just do the bare minimum, I'll just do one method for every question and I would want that method to work everywhere, or that I would only do it one way and I'm not going to try to think of what is happening in the process, right? You need to be versatile, you need to know every perspective of that question, right? So that's the question.